the protocol architectures. There can be 5 layers or 6 layer protocols, 5 layers or 7 layer protocols will be there. Generally, TCP/IP based on 5 layers. So the bottom layer is the physical layer, and next will be the data link layers. And we have discussed it. The physical is not sufficient when you consider the exchange of data. Many more things are needed to manage, to control and manage the exchange. Right. So flow control is one of the techniques that to be followed when you consider the data exchange between the two entities. And the two mechanisms are there. One is stop and flow controls. Another is this one. Today we'll discuss the sliding window flow control. But what we have seen last time, stop and flow controls, we have seen here one frame will be transmitted. Next frame will be transmitted by the transmitting entity only when the acknowledgement is received. So the flow will be stopped. The further frames will not be transmitted unless acknowledgement is received. So the receiving entity can stop the flow of data by withholding the acknowledgement. Right. So that is the case. And we have seen in this case in stop and flow controls how utilization efficiency can be calculated. In this case, always efficiency it is less than 1. We have seen the two scenario when propagation time is greater than the transmission time of the frames, and also when propagation times is less than the transmission time of the frames. The two things are most important that I've seen last times. Timing diagram, we have seen it. And whatever may be the case, in both cases, though in case of propagation time less than 1, less than the transmission time of the frames, we can have more efficiency. But I mean, line is utilized, but still partially it is utilized. I mean, still most of the cases the link will be underutilized. So we have seen it in stop and wait flow controls. Overall, if you see the efficiency, it is always less than 1. It is 1 by 1 plus twice A. That is most important. We have discussed it. Nishant, देखो निशांत, वो शायद MCB गिर गया. So utilization efficiency, it is 1 by 1 plus twice A, where A is the normalized propagation times that you have seen it. Right. Next, so the stop and flow controls is a very useful technique. It is very simple, but because it is very simple and very faithful in the sense that each frame is क्या हुआ? ना वहाँ पर ऑन करो ना तुम उसको देखो सीवीटी में वोल्टेज आ रहा है कि नहीं देखो. हाँ, सीवीटी में नहीं दिया, जनरेटर चल रहा है क्या? ना वहाँ कैसे करोगी? वो जब वहाँ नहीं वोल्टेज आएगा तो यहाँ नहीं है. शायद वो जनरेटर चला. ठीक है, देखें. So you see, it is very faithful technique in the sense that each frame is acknowledged, and the next frame will be transmitted, right? But you see here the link is underutilized, and the situation will be worst when the bit length greater than the transmission time of the frames. That times serious inefficiency will be there, right? Of course, this efficiency can this problem stop and flow control. So it's a very slow process. Right. One frame will be transmitted. Next frame will be transmitted. Then only when acknowledgement is received. So each frame travel all the way to the receiver, and the acknowledgement must travel all the way before the next frames can be sent. So these problems is a very slow process. That is the main drawback of these stop and flow controls. And this problem can be avoided if you can transmit multiple frames at a time. So that is actually the basis of the sliding window flow controls. Here, actually, this carefully you must listen. It is the most important protocols because all the internet or the modern protocols are based on these sliding window flow controls. We'll discuss several protocols, HDLC, PPP protocols, etc. But many more protocols are there. Maybe when you read the advanced paper of the advanced the paper on the data component networkings, many more protocols will see. But all those protocols will be based on modern protocol based will be based on this sliding window flow controls. Sliding window flow controls. So in this case, actually, if you consider two stations A and B, here the concept of the window size is used. Window sized, also it window W frames. Actually, if you consider the two stations, say A and B, two stations, A and B, then you see B initially allocates the buffer space for W frames. The B is the receiver, A is the transmitter. Both way can be full duplex also. All right. Both way it can B can transmit, B can receive also. For the timing, you just assume A is transmitting and B is receiving. So initially B allocates the W frames that the B can transmit. So B can accept W frames. We can accept W frames, and A can transmit. A may be allowed to send the W frames without acknowledgement, right? Without acknowledgement, A can transmit W frames at a times, but not necessary. This actually window. It depends on the number of bits. I mean, here actually frames are numbered. Here sequence number is used. Sequence number is used. Frames are like 1, 2, 3, 1, 2, 3, like these things, right? So, so each frame is labeled. Each frame frames are labeled with the sequence number, right? And B, whenever B say B is receiving frames, so whenever B acknowledges a particular frames with the numbers, then you see acknowledges B acknowledges with this message, say RR. Generally this is used RR RR3. That means B acknowledges B has received the frames 1, 2 and ready to receive the frame number 3, like these things. So multiple frames can be transmitted here without acknowledgement. You just see it. But for stop and flow control, what you have seen it, one frame will be transmitted, next frame will be transmitted. So here next frame transmitted unless acknowledgement is received. But here you see A transmitted at a times. A maximum it can transmit W frames if it is a window size W. But say initially suppose it transmits say 0, 1, 2 like these things, and 1, 2 etc. Maybe more than 3 it has been transmitted. The more than it has transmitted. But if B acknowledges RR3, that means it has received 0, 1, 2. 3 frames have been received and is ready to receive the frames starting with the number 3. So here the sequence number is most important. So frames are numbered. For stop and flow control, there is no such sequence numbers. Keep in mind. So this is actually the thing is this is the basis of this sliding window protocol. That means here multiple frames can be acknowledged at a times. Right. But in this case, of course, we'll see something more important is A will maintain, say A will maintain the sequence numbers, maintain the lists of the sequence numbers that that it can send, and B maintains the sequence number that is prepared to receive. And these are most important, what I'm saying just now. In these protocols, station A maintains the list of numbers, sequence numbers that are allowed to send, and B maintains the sequence numbers that are prepared to receive. Right. So these things can be considered as a window of frames. That's why this W is used, window of frames. Right. We'll see it. The window can be expanded, or window can be shrunk. Right. So there'll be window of frames. So window size is most important. In this case, window size is most important. What will be the window size? Say for 3-bit, if you consider 3-bit, I mean sequence number will be used. So if you can consider a 3-bit field, so the maximum window size will be, what will be the maximum window size? Can you suggest anybody with consider 3-bit field? Anybody? What will be the window size? Sequence number 0, it will be 0 to 7. 0 to 7 frames can be transmitted. 3-bit field 0, 1, 2, 3, 4, 5, 6, 7. So the frames will be numbered like these things, and so we can use modulo 8. Modulo 8 for 3-bit field, right? So and it will be repeated like these things. After transmitting 7, frame number 7. Then next number will be 0. 0, 1, 2, 3, 4, 5, 6, 7, next 0. Right. So for a k-bit field, so we can write the sequence, the range will be, if you consider a k-bit field, if you consider the k-bit field, so the range will be, range of sequence number will be 0 to 2 to the power k minus 1. That's like this in 3-bit. 0 to 2 to the power k minus 1s. Right. So the maximum window size, here it is. Window size, it is actually less than 1, it will be there. 2 to the power k minus 1s. Right. Here also window size, we see it. This window, so what will be the maximum window size, that will see it. For the timings, you see, you consider this maximum window size. In this case, it will be, for k-bit field, it will be 2 to the power k minus 1s. Right. Not 8, actually it will be 1 bit less. Why? That we'll see it. Later on we'll see it. So but 3-bit maximum frequency, maximum bit, maximum frame number can be 0 to 7. Right. So before proceedings, all those things, how now each times the A transmits the frames, its window size will shrink, and each time B receives the frames, its window size also will shrink. Right. And when A receives the acknowledgement, its window size will expand. Similarly, B, when B releases the acknowledgement, that time its window size will expand. So these things, you see, it will be more clear if you see it. For transmitter side, you see what I mentioned. So this is the frames 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7. Next it will be 0 again. 0, 1, 2, 3, 4, 5, 6, 7, like these things. Right. In this way, frames are being transmitted. So a particular scenario, if we just consider, say in this case, say up to frames transmitted, but up to this frame number 5, that is the acknowledged. These are last frames. Last frame, it is acknowledged. So these are the frames sequence number. Frame sequence number 1, 2, 3, 4. In the stop and flow control, these things are not there. Sequence number is not used. So here you see frames are numbered, and so up to these things, say up to this one, it has been acknowledged. And the up to 5 frames acknowledgement has been received. The 6 and 7, so not transmitted but not acknowledged. These frames transmitted but not acknowledged. Acknowledged, right? 6, 7s, and you see these are the frames. The 0, 1, 2, 3, 4. These things. This is window will, here window will shrinks. Window shrinks. Window will shrink from the trailing edge when the frames are transmitted. The frames are transmitted, window will shrink from the trailing edge. Right, and whenever you see, whenever acknowledgement is received, then window will expand. Window expands. Window expands when acknowledgement received. SEK received. So you see it here in this scenario, say 0 to 7, frames already transmitted. Frames already transmitted. Right. A frame is transmitted, but you see here last frame acknowledged, it is these 5. Right. In this case. In this case, the 6 and 7, the frames buffer until acknowledgement. I mean, frames will be buffer. These frames will be buffer at the transmitter, 6 and 7s. So you see, if no acknowledgement, they may be retransmitted. So that's why the frames buffer until acknowledgement. And you see, this is the window. This one. This is the window of frames that may be transmitted. Window of frames that may be transmitted. So this is the transmitter side. You see once again here, they are the frame numbers 0, 1, 2, 3, 4, 5, 6, 7, etc. Right, and here see after transmission, the last frame it is acknowledged, it is 5, but 6 and 7 this frame transmitted, but frame number 6 and 7 not acknowledged, so they will be buffer, right, and the transmitters they may be retransmitted like these things. So until acknowledgement is here, so they will be buffer. And in this context, whenever frames are transmitted, the window size will shrink, and when the acknowledgement is received, window will expand. That's why the name is sliding window flow controls. This protocol is called sliding window flow controls, right? And this is the frame size. This is the frames that are allowed to transmit. Now, you consider the receiver perspectives. Here, the same thing will be there. How window size will shrink and window will expand, depending on the number of frames received and the acknowledgement transmitted. So here you see. So this is 0, 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Again 0, 1, 2, 3, 4, 5, 6, 7. And these things. Right. So here you see last frame acknowledgement up to 5. It is last frame acknowledgement, acknowledged, and you see up to 7s, up to 7, 0 to 7 frames already received. Frames received. But you see, acknowledgement is given up to 5. Right? The frames received, it is the last frame, it is received. Last frame, it is received. Right. And this is the window size that may be accepted. You see these things 0, 1, 2, 3, 4. So window size, initially window size will be fixed, so that this much frames can may be allowed to transmit and this much frames may be allowed to receive. So that is the indication of these window frames that may be window of frames that may be accepted, that may be received or accepted. Initially that will be fixed, right? Right, and in this case also window will shrink. This window will shrink whenever from the trailing edge when the frames are received. As soon as frames received, the window will shrink. Window will shrink. Shrinks. Window shrinks. In this case, when as soon as frame is received, and when in the receiver, window will expand when acknowledgement are sent. When window will expand when acknowledgements are sent. So the two things are there. Okay. These are frames received but acknowledged up to 5, and here the window will shrink when the frames are received, and window will expand when the acknowledgements are sent. So right, and you see, so I told you this, the frames may be these are frames are buffer because they may be retransmitted. And here, of course, you keep in mind the window size, the 3-bit field. Windows maximum window size can be 0 to 7, right? But not necessarily it will be maximum. It can be any maximum. It will be 7, right? Actually, 1 bit when you say 0 to 7, it is 8, but 1 bit less always will be there. That is why that we'll see it later on. So maximum window size can be any numbers, but maximum can be 7, right? So it can be 4 also, it can be 5 also, it can be 6 also, like these things. So these are the things are there. So with this concept, now let us consider one typical case. Then it will be more clear if we consider the frame transmissions and acknowledgement. These are the concept. This is based on this concept. This slide into flow control operates. Now see the actual operation. Say in this one. Okay. Zero, 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. Right. And in the receiver part also you see it. Zero, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. Next, say initially, say this is the window size. It can be not maximum can be 7, but you see 0 to 7 maximum, but 3-bit. So, but it always is less than 1. So still for the timing, say it is say 0 to window size. It is fixed. It is say it can transmit at a time 0 to 6, right? And also B can receive the frames 0 to 6. To 6. Right. Now, with this, now suppose A transmits the frames. Say this is F0, F1, F2. 3 frames A transmitted. So I told you as soon as A transmit frames, its window will shrink. Five, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. Right. So you see A may initially you see window size is fixed. A may transmit 7 frames, 0 to 6, 7 frames. starting with this frame number 0, F0, and after transmitting say 3 pins, say F0, F1, F3, not F2, F2, F0, F1, F2, without acknowledgement, A has shrunk its window. So this times 1, 0, 1, 2. So you see window size will be now this ones. This is the window size, right? We also, when receiving these frames, you see its window will shrink. 5, 6, 7, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7. So you see it here, 0, 1, 2, it has received. If it has received, then you see its window also will shrink. Its window will shrink. Right. Now, say after receiving these frames, B sends the acknowledgement. Receiving these ones, say B sends the acknowledgement. But as soon as it sends the acknowledgement, you see its window will expand. Its window will expand. When it releases the acknowledgement, its window will expand. Zero, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So it's you see 3 to 6 now. It will be, say it is RR 0, 1, 2, 3. So RR3. It will be RR3. So maximum 0 to 6, 7 frames. So starting with the 3, 3, 4, 5, 6, 4 frames plus another 3 frames, 7, 0, 1. So up to 1. Its window will expand up to 1. These ones. So its window expands. Right. Now after receiving this acknowledgement, also A window also will expand. One, two, three, 5, 6, 7, 3, 4, 5, 6, 7. Right. So window size it is 3, 4, 5, 6. Right. Now it will be also 7s. So here it will be up to 1. These ones. When it receives the acknowledgement RR3. So it will now transmit the further frames. This is say F3, F4, F5, F6. So F3, F3, F4, F5, F4, F5, F6. Right. So you see when the frames are received, as usual, its window will shrink. So actually 0, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6, 7, and 2, 3, 4, 5, 6, 7, like these things. So here you see this one is here. So here no. Say scenario will be like these things. So after receiving say frame number 3, say frame number earlier it was 2. It is frame number 2. Right now, say after receiving frame number 3, and say it sends the acknowledgement. So you see, so it will be now up to 2. 1 friends up to 2. And say here, as soon as frame number 3 it is acknowledged, received, it sends the acknowledgement RR4. RR4, right? So RR4 sends the acknowledgement means its window, when it reaches the acknowledgement, its window will expand. So you see maximum can be, it is 7, so it is 4 to 2, right? And so you see here the condition is this, as here the frame number 6. So you see whenever frames are being transmitted by A, so its window will shrink. Before the acknowledgement, 0, 1, 2, 3, 5, 6, 7, 2, 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7, like these things. So here you see, if you 3, 4, 5, 6, 3, 4, 5, 6 then transmitted, so its window will shrink. Window will shrink, right? But as soon as this acknowledgement is received RR4, RR4, this is RR4, then you see its window will expand. It is 0, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So RR4, you see, but by the times this RR4 means it will transmit, it is allowed to transmit frame number 4, but you see it has already been transmitted 4, 5, 6. So the remaining frames actually it may transmit 7 to another 7 frames. It can transmit 7 to 2, 7 to 2, right? And see here what will be the conditions of the receipt. Say this is station A, this is station A, this is station B. So you see here, after receiving these frames, its window also will shrink. Its window will shrink. Zero, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So you see the frames 4, 5, 6 if they received. So actually from 3, if you just consider here, right, because 3 it has been sent the acknowledgement RR of 4 means it has received the frame number 3 and ready to receive the frame number 4, starting with the frame number 4. So you see here 4, 5, but already 4, 5, 6 it is received. So its window will now shrinks to 7 to 2. Right. So in this way, window will expand and window will shrink. Once again, see what I am saying from the very beginnings. So we are considering a 3-bit sequence number, and maximum window size can be 7s. 7 windows. That means 8 frames, right? But always it will be less than 1. That will see it. So actually, it is maximum can be 7 frames, right? So here we're considering 0 to 6, 0 to 6, 7 frames, right? So initially, this window size it is fixed. It can be less than 6 also, maybe 4, maybe 5, like these things, depending upon the requirement. So here it is for a particular case, it is window size, it is 7s. So B is allowed to fixed the window size. So A is allowed to transmit the 7 frames, right? Starting with the 0, right? A may transmit 7 frames beginning with 0, and A can receive the frames this starting with this 0 to 6, right? But now A will A starts transmitting in this case, in the first scenario. So F0, F1, F2, 3 frames, right? So 3 frames, multiple frames are transmitted. But what is not there? This is not the case of stop and flow controls. There you see there 1 frame will be transmitted. Next frame will be transmitted when acknowledgement is received. But here you see 3 frames are transmitted at times, F0, F1, F2, without acknowledgement. You see it here, but as soon as these 3 pins here sliding into flow controls, the 3 pins transmitted, its window size is shrinked. Window size has been shrunk to 3, 4. You see 4, 5, 6, 0, 1, 2, 3 transmitted. So A has shrunk its window, and whenever the frames are received, B's window also will shrink, right? So it is now 3, 4, 5, 6, these ones. Now B transmits the acknowledgements, right? Whenever acknowledgement is transmitted, its window size will expand. So 3, 4, 5, 6 maximum. It's a that means RR3 means here it can it has received the frames up to 2 and ready to receive the frame number 3 onwards. In fact, it can receive from 3 to 1, 7 frames, because you see initially its window size maximum can be 7, 0 to 6. So it can receive starting with the frame number 3 to 1, right? So as soon as it releases the acknowledgement, its window has been expanded, right? Whenever the acknowledgement is received, A will expand its window, say 3, 4, 5, 6 to 7, 0, 1, and these things, right? Next, A transmits the frames because already transmitted F0, F1, F2, and acknowledgement is received. So it will start transmitting the frames from frame number 3. So like this thing, F3, F4, F5, F6. Now as soon as the frame F3 is received, B next transmits the acknowledgement. Say acknowledgement may be multiple frames, or any times acknowledgement can be received, can be transmitted by the receiving entity. So here you see B acknowledges, B transmits the acknowledgement, this RR4, that means it has received the frame number 3 and ready to receive the frame number 4. So it will expand its window. So one frames more. So it is 2 here. It is less, and it will be a window will expand. By the time this acknowledgement will receive here, and as soon as A transmits the window, its window will shrink. You see it here, 701 now. Already 4 frames transmitted, 3, 4, 5, 6, right? But by the times this RR4 will receive here, will reach here, A has already transmitted the frames 4, 5, 6, right? So 4, 5, 6, its window now you see is now this 7012, right? Because 3 frames are transmitted, 4, 5, 6, so 4 more frames will be there. So total 7, so 7012. And here also, if this up to frame 6 it is received. So next you see 4, 5, 6, so 3 already received. So another 4 frames ready to receive 7012. So now the situation will be locked. There will be no such transmission until the A receives the acknowledgement. A can open its window from frame number 7, right? So unless some acknowledgement is received from B, the A will not open its window. That means it must send the RR7. That means it has received the frame number 6 and ready to receive the same number. If this acknowledgement is received, then only A can open its window, like these things. So I have discussed in details. Anybody, if you have any problems, you can ask. The operation sliding window flow controls. Next, we'll see the utilization efficiency of these ones. One thing is there, piggybacking. Next time we'll see it. But anyway, today this much. If you say any questions, but try to understand this protocol is most important. All the modern internet, if we are using email, etc., e-messaging, all the things, these are actually based on this sliding window flow controls. Internet or networking, these are based on networking. Whenever you see data exchange, these are based on this sliding window flow controls. Of course, some error controls technique also will be there, but this is the basis for all data exchange. Any questions? Whether you have followed or not, tell me. Any steps, if you don't follow, you can ask. If you have listened, then only you will ask. If you don't listen, then you will not ask. Any questions? सब लोग सो गया होगा। नो सर, कोई क्वेश्चन नहीं है। इस बार क्विज भी, लेकिन तुम लोग का बहुत मार्क्स कम आया। इट मीन्स यू आर नॉट लिसनिंग। एवरेज 5 आया, सबको दिख रहा है। हम मार्क्स तो भेजेंगे। मार्क्स मिल जाएगा क्या तुम लोग मार्क्स सर मिल गया मार्क्स? यस सर। तुम लोग मार्क्स देख पाया ना? यस। तो हाँ, देखना एवरेज मैक्सिमम को वही 5 आया, 5, 6 से आया, पर जो भी है। But this is most important. If you just go through it, if you not follow, you can ask next time also. But this is the most important protocol I'm saying again and again. Sliding window flow controls. We'll see details also much more many things on these protocols, like say utilization efficiency and timing chart that I have seen it when efficiency will be maximum. I mean, in this case, you'll see one case efficiency will be 1. I mean, link will be filled with the bits, with the frames, that will see it in one case. But other case, it will be slightly less. But anyway, still it is better than, far more better than these top panel flow controls. So this much today. No questions. I'm just.
Excuse me, sir.
Yes.
Sir, please could you upload the slide of last class? Sir, last class I was not able to attend, sir, because of health problems.
Okay, this last class.
Yes, sir. Last class.
Last class means stop and flow controls. Stop and flow. Okay. Okay.